Hello everyone, welcome to another session. Today we are going to talk about analyzing graph to summarize an investigation. Now the first one is the relationship between two variables that we always have to keep in mind, because graph, there's always two variables that we are going to play with, which is x and y. Now we can interpret this relationship between x and y in a few obvious ways. Number one, or I should say the second part, is the gradient of the graph, where we find the gradient is equals to the change of y here over the change of x. Now the change of y is y2 minus y1, which we can see from the graph over here. Yeah. So the y2 is this one, y2 minus y1 over x2 minus x1, and the y2 is actually this point coordinate right here, so you can take the value here, and x2 is the coordinate over here, so you can take the value here. Y1 is the coordinates over here, so you can take the value here, and x1 is right over here, so you can take the coordinates over here. So you just take the coordinates, then you put it in the equation, y2 minus y1 over x2 minus x1, and you can get the gradient. And y2 minus y1, let me just clean it out a bit. Now y2 minus y1 is actually the difference for this value, so you can get this value right here, if you y2 minus y1, and if you take x2 minus x1, you can get the value here. When you take the value of change of y, which is this one, and you divide it by the value of x, or change of x, which is this one, you can get the gradient right here. There we go, beautiful. So yeah, it's basically like that. So when you want to find the gradient, just take the change of y minus over the change of x, so you can get the gradient. All right. Now the next one is we want to find the area under the graph. This is one of the example of graph interpretation. What we can find is the area under the graph. Calculate the area under the graph using the relevant formula for the area. If you want to find, if for example we want to find the area under the graph for this area right here, there we go, this area right here, yeah, we want to find all this area under the graph here. So what we can do is that we can look at the shapes. We can divide this area under the graph into two shapes. The first one is rectangle, and the second one is triangle, and all you have to do is to find the coordinates. All you do to find the coordinates first, which is here and here, to find the length here, and you can find the coordinates for 0 or y1, as it's already mentioned here, minus 0, so you can find the length, the length here. So just take down here times by here, so that you can find the area of rectangle, and the area of triangle, just take the coordinates here and here to find the length here, let me just, I should write length properly, to find the length. There we go. And we already have the height of the triangle, this one, which is the same as the width of the rectangle, so you can just times it by the width of the rectangle or the height to get the area of the triangle. And lastly, when you get both the area of triangle and the area of rectangle, just plus them, so that you can get area under the graph. So that's basically it. Just find the shapes of the area under the graph, so that you can actually find the area under the graph. Yeah, just find the shapes and just separate it. Just use your creativity, look for the easiest way to find the shapes under the graph, so that you can get the area under the graph. Now the next one is the interpolation to determine the value of the physical quantity. if the value of x is given, determine the value of y using interpolation and vice versa. For example, if they already gave the value of x, for example 1.5 here, right, and this is the graph, we can actually find the value of y for this particular point. Yeah, so all you have to do is take your ruler, draw it all up here so that you can get to this point, then draw it to the side so that we can see what's the value of y. For this example, the value of y is around 39, around there. So yeah, you can extrapolate, so you can put beside here the coordinates x 1.5, sorry, let me just write it properly. X is 1.5, and y is around 39. So there we go. By only having the value, the given value of x, if the question only gave the given value of x, which is 1.5, you can actually find the value of y by just looking at the graph and seeing what's the coordinate that is suited with the value of x. Next is the interpolation to make prediction. For example, you have given a experimental data with this line, particularly here, this line right here, this line, right? So what we can do is we can find we can actually predict the line, what is going to happen next. So what you have to do here is just take a ruler and just make a straight line. If it's a straight line of experimental data, just make a straight line until you get to a point where you want to find. So what you can find here is that you can have additional lines, and you can find what is the c-intercept. You can find what is the c-intercept. You can find what is the x-intercept here for the x-axis. You can find many more information by having an experimental data and doing a prediction line. I like to call it a prediction line rather than extrapolation line, because it's a prediction of where the line will be if more data can be obtained. So yeah, that's basically it for our lesson. I hope you get any information that you're looking for. And if you like the video, like and subscribe. And yeah, see you in the next video. Thank you very much.